Good morning, good morning. I would say let's close the door and for the next 2 hours you're mine. So what's the deal today? So today we're going to look at how you set up an ACI fabric from scratch. So myself, my name is Ramses Smeyers. I work for CX, which is, for layman's terms, I work for Cisco Tech. So it basically means if you go for this product and should you have a question around behaviors of the product, you can open a case with one of my teams and we'll be more than happy to assist you. I've been working on ACI from its early birth and I've been going along that journey for the last 4 or 5 years. So what are we going to do today? So today we're going to bring up an ACI fabric from scratch. And I always like to explain it in the beginning, that's all we're going to do. I'm not here to convince you during 2 hours why you need to go for ACI. I'm not going to explain you the business case, the return on your investment, etc. I guess you coming here, what you want to know is how you set it up. So just so that's clear, we won't go into those kind of subjects. So what are we going to have a look at today? Well, first we're going to look at, what is it that you need to install an ACI fabric? What are your prerequisites? We'll inspect our hardware. We will install it. There's 400 people here, so there's enough screws and bolts for all of us to get a lot of fun. We will build a fabric topology. We will build an underlay. We'll build an overlay, everything on top of it. And we will configure the fabric. And at the end, we'll also go over some ways how you can upgrade the fabric, how you can keep your fabric 100% fully online, but still keep on getting our latest fixes, our latest features, etc. So I would say let's dive straight into it. So when you're planning for an ACI fabric, what are the things that you need? What is it that you need to start with? Well, before you start, at least, and we'll do that today, you need 6 routable IP addresses. We need that because the APIC, which are the controllers in the ACI fabric, they need to be managed over out-of-band. So we need to be able to manage them, and each one of them gets a unique IP, so we need to get 3 IP addresses. And we need 3 more IP addresses because the APICs, they come with something we call the CIMC, a lights-out management adapter. If you know from some of our other, let's say, competitors, think ILO, think RSA, things like that. So the CIMC adapter is there if things go wrong. Should you lose your out-of-band management to your APICs, you can still use that CIMC system to get onto the platform, and it will allow us to troubleshoot potentially hardware issues, boot issues, etc. We once in a while see customers forgetting that, and then when they contact Cisco and they have some problems, that's typically something that we have to tell them, look, unfortunately, you didn't configure it. We have some ways around it, but for all good planning purposes, you will now always use 6 IPs. So make sure you configure the CIMC. And then what we need is a functional NTP server. ACI, the fabric, the controllers, they will have potentially 50, 100, 200 leaf switches in the fabric. So that also means, my mic lost a component, but I think it's going to be okay. So that also means that as we have such a gigantic fabric out there, we need to make sure that all our logging, all our events, all our audit events, all our faults are perfect. You need to know exactly when things happened. You want to know when an interface went down. You want to know when a user calls you, I had network issues. You want to make that perfect relationship with, well, you had network issues because you had that problem at that specific time. We see that network event happen. So it's key from the get-go that you install NTP servers. So I'll show you that, and we'll do that today. And then, as all of you are good housekeepers of your data center, we need the serial numbers, and we need them upfront written down. We need to know what device is in which rack. The reason is, and we'll see that later, is that ACI will fully automatically discover the entire fabric. But the only way how it can identify a component is by its serial number. So you'll see when we start the configuration and the setup that in the UI, the only thing we see is serial numbers. So you most likely in your data center want to know what runs where. If you have that kind of interest, write down the serial numbers up front. Okay? Then, optionally, but strongly recommended for management purposes and syslogs and all this kind of functionality is for each leaf that you will connect to the fabric and for each spine and out-of-band management database, an SCP, FTP, and HTTP server that for a backup. You know, and as I said in the beginning, I'm from our technical assistance center. We see sometimes challenges around manipulation changes, etc., where we probably sometimes need to look at backups. I strongly want to advise you that let this be one of the first things you do. And I know how it goes. Some of the people in this room maybe work for a partner. You need to very fast deliver projects. It's often the last thing on the checklist and sometimes forgotten. So make sure you get an SCP, FTP, or HTTP server that you can use to push those backups to. We would advise you to put console systems through all your leaves and spines. That makes sometimes troubleshooting easier when you have the hardware issues, although you don't need the consoles for provisioning. We have a zero-touch provisioning. You unpack, you put it in the fabric, and it's auto-discovered. But should any hardware issues occur somewhere in the next 5-10 years, you could use that to try to understand what happened. We need something called an infrastructure VLAN and a VTAP pool. So what's that? So basically, we're building an overlay, and we're building an overlay that is based on VXLAN. So that means we need to give our leaves and our spines IP addresses in an infrastructure network so they can communicate with each other and build up tunnels on top of that through VXLAN. So we will use the infrastructure VLAN VTAP pool for that. Now, for most of you in this room, the defaults that are offered by the APIC installer will be perfect. There will be a couple of exceptions in this room, and at the end of the session, I'll go over special considerations around VLAP and VTAP pools to make sure that you make the right choice when that step in the wizard comes. But that also means while I'm configuring it, I'm just going to accept the defaults. At the end of the session, we'll discuss some special considerations around it. And then we need the vCenter IP address and the credentials. For all practical purposes today, we're using the admin credentials from vCenter. I understand that's probably not what you want to do. We have nicely documented on Cisco.com what are the minimum requirements, what are the roles required to manage a VMM domain through ACI. Okay. Now, before we start, some more housekeeping. So I'm standing on this stage, and I know we have this application called WebEx Teams. So I can either present or I can answer on WebEx Teams. So that's a little bit the challenge that I'm in. What I do promise at the end of the session is to follow up all your questions on the WebEx Teams. And also feel free, I like these sessions to be interactive. So make sure to ask me questions. If too many questions are coming that could risk us covering all the content, I'll probably throttle a little bit and we'll follow up them at the end of the session. Okay, so with our prerequisites set and with some of our rules agreed for this session, let's start it up. So the first thing we do is we buy the hardware. That is the easy thing, click, click, click on Cisco.com, and the hardware is delivered. And all the boxes arrive. I would have loved to drop all the boxes in this room, make it a team activity. I probably could have done it. There's more than enough people to actually rack this really fast, but we already did the racking for you. There you go. It's a demo, it's a lab thing, so yeah, all the leaves, all the spines, everything is in a single rack. But yeah. So cabling, you see, in generally the cabling goes, and you see it on the screen. There's simple cabling in the setup, but in general, from a cabling perspective, and we'll cover that on some of the next slides, leaf goes to spines, and that's it. There's no leaf-to-leaf cabling, no spine-to-spine cablings. The cabling, if we would have done that here as a team event, the cabling, I would have told you, connect every leaf to every spine, and we would have been done. No complex cabling, no interpretations. No, for my design, I do this, and for that design, I have to do that. No, simple cabling. Very simple. And we'll talk more about later around the VPC then, because that's weird. For people knowing standalone switching, you're thinking, no, if I want to do VPCs, I need that cable. So let's see what actually magically happens. Okay. As I said, the first thing what I would like you to do is I would like you, when the server boots, is to go into the CIMC setup utility and go to the right and configure a CIMC out-of-band lights out management address. It's the first thing you do before you do anything else. Because if you don't do it at this point, the system boots, you start configuring, and the only way to configure it is by bringing down the system, which you won't do. I know how it goes. So you do it immediately, it's the easiest. You know, you do your housekeeping immediately right. Okay? So our setup for today. So it's a simple lab setup. So at the top we have 2 spines. Connected to that spines are 2 leaves, the ones we will work with today. At the bottom we have at the bottom left, and don't worry, you can't read the port numbers at the back, and it's more that you kind of get the topology. So at the bottom left we have a router, we have a UCSB, so to show you how blades connect into the system. We have some bare metal UCS servers on the right. So notice that in our drawing that we have over here, leaves connect to spines. Now, in the setup that I showed you earlier here, you see my nice 3 APICs all together in a rack. Now I have to tell you something. This works because it's at Cisco, and at Cisco we know how to talk to APICs. But in the wild, in the free, APICs don't belong together. They don't like being together. You put them as far away in your data center as possible. If you can, in different rooms. If you can, depending on your setup, in different sites. They don't like being together. Just remember it like that, because you're gonna end up, it's nice, all my controllers in the same rack. But if you lose that rack, that power, you lose all visibility and all management capabilities into your fabric. So make sure that you spread them out as much as you can. They don't need to connect like we did it over here. They don't need to connect to the same leaf pair. Connect them to different leaf pairs, as far away as possible. Because if things happen to leaves, it will only impact one APIC. If things happen to power, to streets, rows of racks, to rooms, you are protected against that. So make sure, just remember, they don't like being together. So make sure you put them far, far away as possible. So then, I did my work very well. So this is my rack layout. I wrote down for every leaf and every spine what is the serial number. And that will help me later on in the process to identify which device is what. And you will see that the whole discovery is based on serial numbers, so this is the only way how I know what's where. I also have my console and network fully configured. So I have my devices over here, I have the ports where I need to connect to, so I know if anything goes wrong. And during our session as well, I'm going to show you how leaf systems get provisioned, how spines get provisioned, each step of the process. So it's nice we have a console of them, because it's the only way to connect to them. And then we need IP addresses. Our IP addresses, as we said earlier, so we need for each APIC an out-of-band IP address, and preferably for the leaves and the spines an IP address as well, which will allow us to do, for example, outgoing syslog, etc. And that will allow you to maybe with third-party systems do certain monitoring, etc. This is our UCS Mini, how it's connected. So we have 2 fabric interconnects in a UCS Mini. They're just really, really like little baby ones, but it's the same concept as our big chassis setups. Notice, and you can actually see it better on our next slide, notice how our router and our bare metal are symmetrically connected. I don't know if you see that. So we can see here, and for the people at the back, so I think it's still big enough. On the left, we see our Nexus 3K. That router goes to leaf 1 at port 1/33. And the router goes to leaf 2 at port 1/33. And that might have been a best practice that you have been using your entire life when you did networking, and I applaud you for that. Now in ACI, this will allow you to create divided by 4 times less policies. So if you go for symmetry, the configuration of policies later on to configure port channels, etc., because most of the things in your data center are dual connected, will become a breeze. It's going to become so nice. So you will see today when we go over the provisioning of our infrastructure, because of the symmetry in place, the amount of modifications we need to do is a lot less. So remember, ACI loves symmetry. Everything you connect symmetric. Also our fabric interconnects, you see fabric interconnect A is connected to port 41 on both leaves. Fabric interconnect B is connected to port 42 on both leaves. Make sense? Okay. So, what is the first thing that we are going to do? So the first thing that we are going to do, we're going to build a fabric topology. So what does that mean? Well, I have these APICs that are newly unpacked. I did no tricks, no videos. They are waiting at a KVM screen, and they're saying press enter to start the setup utility. So we'll do that, and we will go over the setup utility. I'll go over some of the options and explain you why. And then what will happen is we'll do a first leaf discovery. After the first leaf is discovered, we will discover in the next iteration our spines. After our spines are discovered and managed by the fabric, in the next iteration we will discover all the remaining leaves and add them into the fabric. We will then finish our APIC 2 and APIC 3 configuration and form a cluster. And once our cluster is ready, we can start configuring the configuration. So we'll quickly verify the cluster is properly running. We will configure out-of-band management IP addresses, and I'll show you how that goes in the UI. We'll configure an NTP configuration. So we'll, with a couple of simple clicks, configure NTP through our entire fabric. 2 leaves, 50 leaves, 100 leaves. It's that one time that I did that, and it's auto-deployed. And we'll configure a route reflector. And if you have ever done route reflectors and configured them, appreciate, hopefully, the simplicity of that kind of configuration that we will do. Okay, so enough talking. Let's show you how this actually works. So I don't know where I took you. Probably there's a beautiful, see, we've been to Italy now. So let's see. So, as earlier explained, our APIC servers, they come with a lights-out management system. And that is our Cisco Integrated Management Controller. So as I have properly configured the CIMC address, and that's the only thing I had to do to trick you, because else we couldn't, from here in Barcelona, go on my systems in Brussels. So the CIMC has been configured with an IP address, and it allows us to take a remote KVM, which allows us to now manage over a KVM connection our APIC server. So when the APIC server boots, it will tell you in very big letters, press any key to continue. So we know the any key, so let's press the any key, and let's see how that goes. So a quick one at the back of the room, can you read this? Is it doable? Raise your hand if you can't read it. I have a couple of people, so I'll increase it a little bit more, as much as I can. There you go. That's as much as I can, so I hope that's good. Yeah, I see a thumbs up. You know, I'm a diver. For me, thumbs up means let's go up. So, you know, I do like this in general. Okay, so enter the fabric name. So the first thing we need to do is we need to give our fabric a name. Now, I have a huge amount of pods in Brussels, all kind of pods that we have for our TAC engineers, you know, because when you call, we need to make sure that we can actually do some reproductions of the challenges that you are facing. So I'm going to call this one in our lab pod 12. And it's a little bit slower because I made it bigger for the back of the room. So you're going to have to bear with me. Okay. The next thing I need to do is I need to give the fabric an ID. So depending if you're going to grow over multiple sites, you're going to use features such as multipod, MSC, Golf, and there are nice sessions on the next days on that, or in the catalog already available. We need to think about this number. This is our initial fabric, our initial pod, so fabric 1 is going to be more than enough. Okay, so we accept the default. And then what I need to say is, I need to say the amount of active controllers. Now, the minimum supported amount of controllers is 3. And I understand that you will see later on, when you have 1, we can start, but we do not support you for production. There is going to be very big warnings, and you'll see that when we log in with 1 active controller, that you need to go to more than 2 controllers, being 3. You're going to ask me, look, do I need to do 3 or 9? We have scalability guides that clearly explain to you, depending on the workload that you have in the fabric, the amount of leaves, the amount of endpoints, how many API controllers you need. So I would refer you to that guide, which will clearly explain to you the amount of controllers that you need in your setup. So we're going to use 3 controllers today. And we have to give a pod ID. A pod ID is, again, it refers to our multi-pod MSC, multi-site setups. We're going to accept the default 1. If later on we need to grow, some of our new pods will become 2. Okay? Next thing we need to say, is this a standby controller? So there's a functionality called standby controller where if you have 3 APICs, you can put a 4th APIC as a standby controller. Should anything happen to your 3 APICs, fully automatically a standby controller joins the fabric and takes over the functionality of the failing APIC. This is to make sure that your control plane, from a management perspective, not control plane, data plane in the fabric, but let's say the management controller interfaces stay online, that you keep visibility. So this is a protection for you. It is commonly used also in multi-site deployments, where we typically have on one location 2 controllers and another location 1 controller. So if you have a standby, we can get a quorum, we call it, a majority again, and then we can come online. Was there a question there? So the question is, look, I've installed my fabric with the instructions that you set with 3 controllers. And later on, I would like to add more controllers because from a scalability perspective, I need to increase. So the question is, can I do that? Yes, you can, of course. So you can increase the amount of controllers you need, and then you can keep on growing the fabric. Next is a feature called APIC-X. There are a couple of sessions this week around new management features into ACI. Products like Network Insight Advisor, etc. They require a platform called APIC-X, and that is where this question is referring to. From your perspective now, we're setting up a simple startup fabric. The question is no, this is not an APIC-X. Now we need to tell the setup utility what is the IP address of this controller, what is the controller ID of this controller. This is our first APIC, so this is controller 1. So I'm going to accept the default again. You see, it's a lot of enter. I don't have to type in a lot. I need to give the controller a name. I'm OK with APIC 1, so let's accept that. I need to fill in a tab address pool. I told you earlier today that we will discuss some considerations around the tab pool at the end, so we are going to accept the default. OK. We need to fill in something called the infrastructure VLAN. So I'm going to fill in the infrastructure VLAN that we use for this setup, which is 3912. You can accept a default. Well, there's no default anymore. Sorry, in the past we had one. So you need to give a VLAN number. Again, I'll talk at the end of the session what the implications of choosing a number here are, when that ever could cause a challenge. We need to create a BD multicast GIPO pool. We'll take the default. And then we need to say, look, do you want to enable IPv6 or not? Some of you might say yes, some of you might say no. In our setup, we're going to say no. And then we need to give our APIC an IP address. Now I have that nicely in my document here on the left. I have that nice table, so I'm going to fill that in. There you go. And I will fill in a gateway. There you go. The next question is, after the, this has been following us for 20, 30 years, how to duplex, and it's incredible how it's still there. So I don't want strong passwords because I have to enter a really complex one. And I will give it a password. And most likely it will ask me to fill it in again. We get your standard question, do you want to change any of the defaults? And no, and now the APIC will continue its internal setup and it will start configuring all its services. So, let's go back to our topology. So what's going to happen now? So if we look at our topology, there we go. Our APIC 1, which is at the top, you know, the top over there, I think, which, you know, it's even small for me, you see. So it's one of those three at the top. Our APIC 1 is connected into the fabric. And it's connected to 2 leaves. Now, due to the way how we implemented the connectivity of the APIC into the fabric, only one of the 2 leaves will be visible. We use an active standby setup from the APIC perspective. They connect directly into the leaf. So the connection that is active, the APIC will authenticate itself with that leaf, and that leaf will fully automatically detect there is an APIC, and it will auto-provision the port where the APIC is connected as an APIC port and start up the discovery cycle. The APIC will then start discovering the fabric. I apologize. Now, of course, you can't just plug in any leaf to any APIC, and you can't just plug in any APIC to any fabric. That would not be good. So what we need to do is, we need to go in APIC 1, and we need to start discovering the fabric. And the first thing that will happen, and you will see that when we log into ACI, is it will see a leaf based with a serial number. And we will need to tell the APIC, this leaf with that serial number, you have to manage it. When we say you have to manage it, it will be added into the fabric, and the leaf will become fully managed. Once the leaf is fully managed, we continue our discovery process. What are the next devices we will see when we run our discovery? The spines, correct. People are awake at this earlier time. So the next one are the spines. And we will add the spines into the fabric. We will know who they are based on their serial numbers. And in the last iteration, our 3rd discovery cycle, we will find all the other remaining leaves. If that is 1, if that is 5, because actually in our case you're going to see 5 leaves suddenly discovered, or if that is 200, that's going to be in one go. Because we need a 3-stage discovery cycle. So let's have a look. Let's see where our APIC is. Let's go back. So our device is fully configured. Let's go to our browser. And the moment I'm switching to the UI, it's going to be faster. Yeah, there you go. So here's our APIC. See, I need to accept the SSL certificate. And there you go. Now I've been a little bit tricking you, because if you would have gone from the setup utility straight to this browser, this probably wouldn't have worked. So it takes a couple of minutes to get everything internally done. So when you do this yourself, run the setup utility, go get a coffee, come back, and you should normally be able to log in. Or just listen to my recording and all. That's more than enough time. So we log in with the credentials that we have configured during our setup. And if all goes well, see, not yet. See, you need to wait a little bit. It's also the live demo factor, you know, it's always a little bit of a challenge. There you go. See, I'm going to give it one more try. Yes, shoot. Yes. Yeah. Yeah, so the question is, look, this CIMC IP address that I need to choose, what subnet do I pick? Do I put it in a subnet that is the same, maybe connected into the fabric, or in the same as your APICs? You know, the more different subnets and the more different management infrastructures you have, the better, of course. We would strongly advise you to not connect it into the fabric. We have seen customers doing that, and I understand you often have certain limitations. But at least connect your CIMCs and the APIC management addresses to a separate out-of-band network. If over there you can separate it even more, the better. So that's in generally the advice around it. So let's hope now we waited long enough. We'll see. I think it's better. We're not getting an error immediately. I'm going to have high hopes. So what will happen once we log in, because we log in for the first time, a wizard will launch. It will give us all these kind of advice and training videos, etc. So we'll quickly click that away. See, that's the thing what I was waiting for. Now we're good. Yeah, now I'm 100% confident we can log in because we got a second cert. There you go. No, else I have videos. Don't worry. I have 2 hours of videos, but it's a little bit better like this. So we have this first-time wizard. I'm just going to click it away. You have my session, so we don't need these videos. So we log into the Fabric. Now I know at the back you're thinking I can't possibly read this. So I'm going to help you. How is that at the back? It's good? Yeah? Raise your hand if you really can't read it. 1. I can increase a little bit more, but the UI is going to get really bloated. So there's some empty seats if you really want. Because if I start getting like this, one more, the screens you will see. I'll do my best. I'll keep it at this, and we'll see if it works or not. Okay? Yes, gentleman says yes. So the first thing we do is we go to Fabric, and we go to our Fabric membership. And we're going to look at nodes pending registration. Look at that. SAL 19079J47. And that device is, and we are properly prepared, leaf 1. And this is where it's really key that you understand that you have to have that table. Because there's just no other way that you understand. Come on. See, I'm trying to switch the input. Yes, I got it. It's a little bit slower here. So what we now need to do is we need to add this leaf to the Fabric. And if we look this from the leaf perspective, what actually is happening, and let me show you that. So this is our leaf. And our leaf at the moment, we see non-login. It doesn't have a name. If I type admin, I can just log in. There you go. How did we actually discover each other? Just so that you understand, the Fabric ships by default with LLDP, TLVs, etc., and that allows us to discover. So we can see over here that, and let me make it a little bit bigger as well. There you go. So you can see over here that our leaf has discovered APIC 1 and vice versa. APIC 1 has discovered the leaf, and based on that, discovery is happening. So let's go back to our leaf. So what we will do is we will register this leaf. We'll give it a node ID. What node ID? Well, you choose. I like giving my leaves in the range of 100. I like giving my spines in the range of 200. That's easy for me. Yes? Yeah, so the question is, why first leaf 1 and not leaf 2? It's pure coincidence. Because the APIC is active standby. You never know who's active and who's standby. Depends on the boot up sequence of the leaves. The first one that's there, he takes it. Okay? So I'm going to give it a node name. I'm going to give it leaf 1. And I'm going to register it in the Fabric. So what's now going to happen is they're going to negotiate through hardware-shipped SSL certificates on the leaf with each other. They will trust automatically because it's vendor certificate signed. They will trust each other. They will start the setup cycle. What we will do is we will provision the overlay. We will provision an IP address out of that tab pool, set up all the management interfaces, and we will start controlling that leaf out of the APIC. And we will notice that our nodes pending registration, over here, this leaf will disappear, and it will move under registered nodes. And once it appears on the registered node, we will also see that the leaf receives an IP address, and we will get that information. Look, we have lost the leaf. So if we now go to registered nodes, we can see the leaf over here, we can see it has an IP address, and we can see our discovery has started. Also here we already see that it has a host name. Leaf 1 is being pushed to this leaf now, and depending on where we now are in the setup cycle, I can no longer just log in with admin. See, we still need to wait a little bit. See, leaf is now part of a fabric, and now I need to type a password. That password credential is the same as my administrative credential of my API controller. Let's see if it allows me to log in. So now, of course, as I explained, the next step of our discovery cycle will start immediately. The leaf is managed. The leaf over CDP can see spines, over LLDP, sorry, can see spines. Based on that, we will continue the discovery, and we will actually start discovering the spines in the fabric. It will take a while, it's still in the setup cycle. So let's go to nodes pending registration. If we go here down now, see, we can clearly see that we now have 2 more spines. And I'll make it just one step smaller. I hope that's still okay for the back. So we can see our JK has been discovered at the end, and we can see our HV. So JK is going to be spine 2. So I'm going to register that. Yep. My spines, I like giving them an ID in the range of 200. So this is going to be spine 2, register. And the other one, I'm going to register HV as spine 1. And notice he automatically discovered this is a spine. So it's now being registered. And we can see that here, just for completeness, there we go. So you can see over here from an LLDP perspective, this is how they were being discovered. See, we could see these switches, because every leaf have 2 connectors to the spines. So that's how we did this discovery. We noticed there are spines. Notice that this is the zero-touch provisioning that I talked about in the beginning. I don't have to be on this console. The only thing we did was show commands. Because outside on the box is a serial number. Your racking team has properly done the inventory, so you know exactly what serial numbers are where. So you don't need console connections, and we have a zero-touch provisioning of your entire infrastructure. Apex, they ship once you launch an order. Normally you order them per tree. They all ship with the exact same code. The leaves and spines will be auto-discovered, and after that all software will be synchronized. So that's really the power of that part. If I go back over here, you can see that now my spines are getting discovered. Spines take a little bit longer, let's say a minute longer. Once the spines are discovered, we will immediately continue our discovery process and discover all remaining leaves in our fabric. Sometimes they ask the question, look, in the next phase I'm going to discover 200 leaves. That's really a lot of work, How can I register all these leaves into my fabric? That is just way too much work. Well, feel free, if you're interested in that, to come at the end of the session. ACI ships with something called a REST API, which is an API you can use to automate. Nothing stops you to register your 200 leaves through API calls and just bulk load it in. There's even, if you like Ansible, there's even Ansible scripts that will allow you to do these provisionings. So if you're interested in that part, come at the end of the session. I'll give you some pointers how to explore that. So yes, today we'll do everything manually in our session. Everything is automatable through APIs that you can have a much more fast pace deploy hundreds and hundreds and hundreds of interfaces. So we will notice now, look, although the spines are not fully discovered yet, the next discovery phases are already starting. And look, all our other leaves have been discovered in the next run immediately. So let's look for leaf 2. Leaf 2 is the leaf ending with HXH. There you go. So I'm going to register this. I'll check it again. HXH. Yes, that's leaf 2. We're good. So I'm going to give this as an ID 102, and I will give it a name leaf 2. There you go. So this is our last leaf that we need to discover. Notice that ACI automatically finds the model of those leaves and will automatically know as a consequence of that what is possible to be configured on those devices. If you're a graphical person, there's this nice topology. As long as you have small fabrics, these topology views work. Once you have your dream fabric, which is 100 to 150 leaves, they become incredibly bloated. But let's quickly see. I calculate in the beginning with all the discovery, etc. It needs to retrieve a lot of this information. So, and again, as said, so if we now go to our last leaf, while that's loading, we will notice that now, see, our leaf 2 is already managed and is already joining the fabric. In the same way, this was our third discovery cycle, we would have fully automatically imported all the other leaves, and now the entire fabric is ready for management. All of this because we obey to a strict cabling concept, and this is our initial, what we already have managed. And you will see, as we discover more into the fabric, we will see the screen updating more. So we now have one AP controller. We have 2 leaves and 2 spines. Our setup has been discovered. What is the next step that we do? Yes, we configure our next controllers. We have AP controller 2, and we have AP controller 3 that still needs to be added into the fabric. So let's do that. So I'm going to minimize this, and I'm going to go to the next one. So this is APIC 1. You can go. There you go. And you will notice that we have a little bit of smaller amount of questions to answer. There you go. I'm making it as big as I can for the back of the room. So over here as well, you press Enter to continue. The setup utility will start. Now what is important is that you have written down exactly what you wrote down in the APIC 1 initial configuration, because the values need to match. You know, we need to give this thing a tap pool. The tap pool gives the IP address to the APIC. If you give the wrong tap pool to the second APIC, well, he can't connect the first APIC because he's not in the same network. So they can't talk to each other. So, and we need to make sure that the infrastructure VLAN matches. We need to make sure that the fabric name matches, that the tap pools, that everything matches. So make sure you correctly write down what you did in your first APIC controller setup. So our setup is pod 12, so I'm typing that. There you go. It's Fabric ID 1. It is 3 active controllers. These are all the same questions as we had earlier. Pod ID 1. Standby controller, no. APIC X, no. This is the second controller. APIC 2 is a good name. We accept the default tap pool. We choose our infrastructure VLAN, which is the exact same as I typed earlier. We don't want IPv6. We type in the IP address. And we type in the gateway. And we're done. So we need to type a password over here that will be automatically synchronized from the APIC number 1. So this is APIC number 2 that is done now. So we'll go to our last remaining APIC. There you go. And we'll do it again. And notice that if you would have had 5 APICs, 7 APICs, 9 APICs, the way how you would do this, the sequence would be exactly the same. So we go now again, we hit Enter. You know, and now I can call somebody from the room to test if you have been paying attention, because it's a very repetitive process that we're doing here. Yes? So as said, because it would be too deep for this session, so the question is, look, what's the difference between a Fabric ID and a pod ID? We can either take it at the end of line or watch some sessions on the Cisco Live Catalog or go to them around multi-pods and around multi-site controller. These are basically IDs and features that allow you to stretch fabrics over multiple data centers. So for all practical purposes, this is our first pod, we take 1. If you want to know more about it, let's take it at the end, or I can refer you to some of the sessions. I hope that's okay for you, because we can talk 2-3 hours on that. There's a lot of different possibilities there. So I give this fabric a name. Again, Fabric ID 1, 3 active controllers, pod ID 1, no standby controller, no APIC X, controller tree, the name is good, the tab pool is good, the infrastructure VLAN is 3912. We do not want an IPv6, and we give it the right address. And this setup is now continuing as well. So now if we go back into our fabric, because that's where all the action is happening, let me just minimize this one because it will make my RDP a lot faster. Yes, there we go. Now we're back into a fast RDP. So we go back into our fabric, you get these weird messages, and that's normal because the fabric is now, some of the fabric services are restarting because the cluster is now fully forming. So we'll quickly just reload this screen. There you go. And now what we can go is to System, and under System we will have controllers. And under our controllers we will see our topology, and we will normally see over here that slowly more controllers are entering our system. So what is now happening is that APIC 2 and APIC 3 are joining into the fabric. They are synchronizing based on, because they have the exact same pod name, and they have the exact same infrastructure and VLAN pool. They will start synchronizing all the data, and based on that, they will form a cluster. So let's give it a little bit more time. And you already start seeing messages about AP controllers not being healthy because the cluster is automatically forming, see? So I can now already see that I have APIC 1 and APIC 2 that are joining the fabric. And give it a little bit more time, and we will see APIC 3 appearing as well. That's all you need to do. You don't need to configure high availability. You don't need to do anything of that. You know, that's it. We are now fully high available. If an APIC fails, it's transparent. If the second APIC fails, so if you lose 2 out of 3 APICs, the fabric will automatically go into a protection mode, and it becomes read-only. You still have visibility into the fabric, but you go into a read-only state, and you need to recover them. When we lose the last one, it's done. So you can always lose one APIC, and that is also in the same way that we are upgrading the infrastructure. We can remove one APIC out of the fabric, second one, etc., etc. Yes, shoot. Yeah. So the question is, look, when an APIC fails, to what IP address do I connect? Well, the simple answer is to the IP address of the other APIC. Yeah, so there is no high availability, there is no clustering, there is none of that. To keep simplicity. So that basically means we prefer that your southbound systems that are over APIs provisioning us automatically verify which one of our APICs is available over our REST API and provide and sync all the configuration to there. So there's no such thing as a high availability IP to keep simplicity into the fabric. Yes? You mean from a VLAN perspective? Yeah, so the question is, can the management IP addresses of my APICs, can they be in different VLANs? Of course they can, and often you put the APICs on different sites, so they're automatically going to have different VLANs because you normally on out-of-band on stretch L2. So yes, of course, that's... So the question is around replication, then how do they replicate? Well, they don't replicate on their out-of-band IP addresses. They replicate within the fabric. Out of that tab pool, they get an IP address, they automatically configure that IP address, and they do that based on internal fabric communication. So the out-of-band is pure out-of-band. Clusters, etc., have nothing to do with that. So we'll give it one more refresh, else you have to trust me and we come back later. Because you see that it takes a little bit more time. Ah, there you go. APIC 3 is coming online as well. So you will see now our topology from an APIC perspective. And we also see when we go to fabric topology, here we go. So we see our fabric is now fully discovered. We have spines, we have leaves, and we have apex. Of course, if you have 100 leaves, this picture gets a little bit busy. So that's probably, it's good in the beginning to have a look at, to show, make a screenshot to show your manager it's up. After that, you typically don't use this screen anymore. Okay, so what was the next step? What was the next thing we would do? Next thing we would do is give our leaves and spines an IP address to configure a policy so that they can receive the right configuration. So in order to do that, we go to one of our tenants, and there's a system built-in tenant called management. So we go to that tenant, and in that tenant, we have node management addresses, and we can statically assign IP addresses to leaves and spines. We can do that in pools. We can say leaves 101 up to leaf 199, this is the pool of IP addresses, go. Or you can say, no, I want that leaf to have that IP address. And I'm guessing most of you are not large-scale, massive cloud providers with 10,000 leaves, and you don't really care which IP is linked to what leaf. So most of you probably have a tight relationship to your devices. So let's do that. Now, the first thing we need to do is we also still need to give our controllers a policy. We use the setup wizard, but that's just initially. If later on we want to change the IP address of the controllers, we can only do it through a policy over here. So let's give our controllers a correctly configured IP address, which is 10.48.22.69. I'm going to put that in my copy buffer, because we're going to have to type it a lot. So this is the official way to give through ACI your controllers, which is node ID 1, an IP address. If now I want to change the out-of-band address of my controller 1, the only thing I need to do is change this policy to a different IP, and the controller will receive a new IP address. So I'll quickly do that for all controllers. So controller 2. And we will do that by controller 3. And notice we push configuration to controllers in Fabric, so it's okay to change these addresses. There you go. And then the next thing what I would like to give an IP address is my leaves and my spines. So let's do that as well. I gave my leaves and spines these IDs. So ID 101 is my first leaf. Yes. I understand, and it is unfortunately how it is. So the question is, why are these APIC IPs not automatically, why are these policies not automatically created? I would say because. Unfortunately, it's not done. I am with you. So it's maybe a feature that we could ask engineering to implement. Yeah, unfortunately. So we do the same over here. So we give the leaf an IP address, 77. There you go. Submit. And we give leaf number 2 an IP address. 102, 102. We're almost done with the boring stuff, huh? But it's all part of it. There you go. So now we have our APIC and our leaves having an IP address. The last remaining ones are the spines, correct. $75. These are really the moments if I make a mistake, it's not good, so I have to be careful. Can you repeat? Yeah, so the question is again, can I manage this with Ansible? Yes. And come to me at the end of the session, I will click a magical button and all the other leaves are suddenly registered. I don't want to do it. I want to keep the session now simple so we only have a couple of leaves. But if you would like to automate this, yes, by all means, please automate this. Automate everything we do today. Maybe I gave a session on Monday. Our entire session we are doing today, on Monday in that session, we did in 1 minute. We run one script, and everything we do today, we run in 1 minute. We were done. Because we needed that as a base to continue. We can discuss about that at the end, yes. So if you would like some of these scripts, I can give you some pointers around that, yes. That is, by all means, we will. And I'll drop a reference in the spot. Make sure on the WebEx Teams to ask me, and we'll give you some pointers to the Ansible roles and models that we have available. Okay. So our last one. So the spine is 76. That's our spine number 2. Yep. And off we go. So now this means we can now SSH to our leaves and spines. And if you don't trust me, well, 1048.22.77, which is our leaf. There you go. Admin. Secret password. There we go, leaf 1. Fully automatically now IP addresses have been configured. Notice we have configured an IP address without having to go on the console of the device. Zero touch provisioning out of our controllers. Okay, with our IP addresses in place, let's configure something that will use these IP addresses. I would like to configure on my entire fabric NTP. So how do I do that? Well, to configure NTP, we go to Fabric, and we go to Fabric Policies, and we go to our pods. And in our pod, we have a default profile, here, we have a policy group. And what we're going to do is we're going to create a new pod policy group. I'm going to give it a name, pod 12. And I'm going to give it a date-time policy. Okay? I can give it the default, or I can create a new one. So let's take the default, and let's change the default policy in the system. Okay? Default, it's enabled. We go down, and I'm going to add an NTP server. You can, by the way, use the default policies and change them, or you can create policies yourself. I'm going to give the IP address of my NTP server. I'm going to say this is preferred and do it over my out-of-band network. Submit. And I'm going to close. This is active now, submit. So is this now active on my switches? Well, let's have a look. Let's go to our policies, and in our policies to the pod policies, we go to our date-time policy, and look at our default policy, and look at my NTP server, and look at operational. Aye. It's not on our leaves and spines. The reason is because we have created a beautiful policy, but we didn't apply it on our pods. So you need to link the policies you have now created to the pod. So we go to our pod profile default. Here you go. Here's our default profile. And I'm going to select pod 12. I'm going to submit. It will tell you, look, I'm going to now send this policy to APIC 1, 2, 3, leaf 1, 2, and spine 1 and 2. What I would like you to realize here, and I will keep on repeating that as we go through this session, great power comes with great responsibilities. And please realize that. We are making centralized policies that are being linked to potentially hundreds or thousands of objects. That means if I do a change in this NTP policy, it will immediately affect all leaves. And I'll keep that in mind. Somewhere during the setup, we're going to create a port channel policy, and I'll refer to this again. Because really, be very careful when you affect a lot of objects. And ACI will always have this pop-up telling you, policy usage warning, be careful when you are applying this policy. Because all these devices are using another policy, so when you submit this, you're going to impact all these devices. So don't get a habit of default clicking that away. Now if I go to operational tab, it's going to be loading. It's going to take a while, because all the leaves have to pick it up now, but after a couple of minutes, we will see them starting to synchronize. And the NTP servers now on the APICs already, they start synchronizing immediately. See, here you go. See? So you will see they will slowly synchronize that part. The last thing that we need to do is, I told you I would like to create a route reflector. Now remember, for some of you, the amount of work that takes in a traditional networking setup. So I'm going to go here, and I'm going to say BGP route reflector policy. I'm going to create default. I'm going to change my default. Here you go. I need to give it an autonomous system number. So I'll give it a number, 555. There you go. And I have to say which nodes in my network, which spines, are route reflectors, because I might maybe not need to all my spines. And for those that don't know what a route reflector is, basically think I have external connectivity on a leaf. I have 50 other leaves. For those leaves to receive the routes of that external, we call it a border leaf, we need a route reflector to reflect those routes into the fabric. That's, for all simplicity, what a route reflector in ACI is. So I'll add spine 1. I'll add spine 2. I'll click Submit. I click Submit. And I click Submit. Yes. That's it. Route reflectors are done. So there's nothing more that we need to do. Yeah, sorry. So nothing more we need to do. Now, in our fabric, the route reflectors are configured. If now external routes come in, they will automatically be propagated to the fabric. All the configuration for that has been done. So with our fabric now having management addresses, with our fabric now having NTP, and with our fabric now having route reflectors, we can go to the next steps. Yeah, question? So the question is, do we need to specify route reflectors for border leaves? No, no, no. Spines are route reflectors, that's it. And automatically ACI will pick up from the borders the right routes and reflect them into the fabric. Okay, yes? Can you repeat? Yes? Which RPs are taken for what? So the question is, look, if I configure both IPv4 and IPv6 from a management perspective to my leaves and spines, which one are preferred? There's the one that you connect to. So it basically depends. Underlying it's a Linux, it uses the Linux routing table. So when they do outgoing connection, based on if you have an IPv6 or IPv4 address, we will source from that. When we will manage it, you will manage it with one of those two addresses, and that's going to be used. In Fabric, remember, we don't use any of the out-of-band stuff. We don't use any of the management IP addresses. So it's only from our tab pool. Internally, the Fabric functions on the tab pool that we have provided. Okay? Excellent. So let's go to the next step. And I hope this thing is now faster. Yeah, look at that. Before it was not being very kind to me. So we have configured our initial setup. And now let's go further into our demo. Well, the next thing we need to do is we need to bring workload into the fabric. For that, we are going to do a VMware integration. We will do a bare metal integration. We will create tenant and EPGs. And we will bring external connectivity into the fabric. Okay, you up to that? Excellent. So, ACI ships with built-in wizards that will allow us to configure our fabric. And you can reach them over here. Now, for all practical purposes, let me quickly also show you our setup. So we have a VMware server running. And you notice I'm still a big fan of this client. I've yet to take the switch to the web browser of this vendor. And for this demo, it's really faster, so it's nicer. So we have this setup. I know at the back it's a little bit small, but it doesn't matter. You can't read it. It's just from an object perspective that you see it. So we have VMs over here on the left. We have a setup under networking. We have standard networking for the people knowing VMware. There's no VDS there. And we have a data center called Pod 12. So what we will do is we will now add the first connectivity to our Fabric interconnect. So let's do that. Our Fabric interconnect is connected on port 41 into the Fabric. I'm going to be 100% sure on this screen. Yeah, there you go, on port 41. So we will configure that. So we're going to create an interface and VPC. Now, the first thing I need to do is I want to create a VPC, so I need to create a VPC pair. And some of you might be familiar with some of our other platforms where you have to type in a lot of commands to make a VPC pair. So let's do that. I'm going to say, well, my VPC domain ID for my first pair of switches is 101. Switch 1, switch 2, save, submit. We're done. VPC has been created. Switches are configured, everything is done for it. You might think, but Ramses, there is no cable between our leaves. How can this happen? It's over the fabric. So VPC communication, all the classical communication that you know in VPCs is over the fabric, over the leaf-spine connectivity. So we're done. VPCs are done. Okay. Next thing we will do is we will create our first connection to our Fabric Interconnect A. So we're going to select our switches. And on those switches, I'm going to configure on port 1/41 a VPC. And I'm going to connect it, call it FIA. And you want to give these policies good names. The one on the top I didn't rename because I think it's good, a switch profile called 101, 102. I know it's switch profile 101, 102. But this is port 1/41. That's Fabric Interconnect A. So you probably might want to change this name. I'm going to create a CDP policy, and I'm going to say, well, CDP, I don't want it. Disable it. Submit. And LDP, yeah, I like that. There you go, enabled. And this is a port channel, so I need to tell what port channel do I need to use. Well, I'm going to call it LACP active. And I will put it on LACP active. Yeah, there you go. Now notice, I called this port channel policy LACP active. What I configure in it, that's just what I selected in this drop-down. And I told you earlier, great power comes with great responsibility. If I link this port channel policy to hundreds of port channels, and I go back and I change this LACP active port channel policy to something else, I have an impact on hundreds of port channels. So realize when you do these kind of changes that pop-ups come that explain you the impact. Read it. Don't auto-accept it. And I know you have this habit, pop-ups, yes, 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 continue. Be careful. Okay. We scroll down, and we would like to integrate with an ESXi server. So we're going to say, look, I would like to create a new domain. The VLAN pool that you will use for that is 1001 to 1100. Yes. And what is the login for your vCenter? There you go. We give it a password. There you go. I need to tell it what is the vCenter that you will be managing. Yeah, there you go. I'm going to say create a VDS with version 5.5. Depends what your ESXi servers are. You can play with that. Okay, and I'm going to type the data center name, which was pod 12. I'm going to click OK. We'll talk more about what I'm doing now because a Fabric Interconnect has a certain way how it connects in. From ACI to the Fabric Interconnect, we're talking about an LACP port channel. From the Fabric Interconnect to the blade, we're talking about 2 individual links. More about that at the end of the session, if you're a little bit curious about what's happening here. Yeah? The question is, does the vCenter need to be reachable using the out-of-band network? Yes, or in-band. You can also configure an in-band specific VLAN pool, and you can manage it in-band. So either in-band or out-band, you can manage these devices. Okay. I'm going to say use as a vSwitch policy LLDP. We're going to click Save. Save and Submit. And if all goes well, look at that. Immediately, we see a vSwitch being created on VMware. Great. Now, I have more to do because I have a second Fabric Interconnect. So let me quickly configure that one. I'm going to click on the left on my switch selector. I'm going to select my Fabric Interconnect. There you go. I'm going to say again, this is a VPC 1/42 FI-B. CDP policy off, LDP policy on, port channel policy LACP active. I'm just reusing everything that's there. I'm going to say choose my ESXi host, my domain that I've already created. There you go, VMM. I still have to select the port channel mode and LDP. We talk about that at the end of the session. And I probably forgot something somewhere. There you go, sorry. I click Save, Save, and Submit. So now all policies have been created, and we will normally see the links are coming up. It's going to still take a while, and we will slowly see, look, this is up already, this port channel policy, this port channel from a UCS perspective. And this one is still slowly coming up. So ACI has now configured all the policies. Now, for example, my VLAN, my switch policy that I have created is, for example, under interface, leaf, profiles. Here is my switch, and here are some of those policies. Now, all of that has been done for us through the wizards. Now, are we now done? Well, let's look at virtual networking. Let's look at VMM. Here we go. Here is our controller. I can see my hypervisors over here. They're dynamically discovered. And I can see the information here. But notice I don't see information from the controller perspective where it connects to. So what I still need to do is, if you know ASXi, I need to add my servers to the VDS. ACI doesn't know that, of course. It doesn't know which servers are what. It needs to know what interfaces to use. So the VMware admin still needs to go to Add Host, select the right servers, and you have done your homework properly, so you know exactly what NICs you need to select here. Next, next, finish. The servers will now be added to the VMM, and we can see the hosts are in there now. And that means if I refresh this page, we can now see. One second. Yeah, let's do, typically what I do is trigger. You need to typically wait a couple of minutes, so I'll quickly trigger an inventory sync, and that should do it. Yeah, hypervisors. There you go. And look at that. We can now see that we are connected to UCS-A and UCS-B. Now let's take a step back. What have we been doing here now? We have, in ACI, we created the port channels to manage this fabric interconnect. We did a VMM integration. We now, from an ACI perspective, manage vCenter and the ESXi. We know from a vCenter perspective over ASXi where the servers are connected to. They're connected to Fabric Interconnect A and B. From ACI, we get the exact same information from those leaves over LLDP. So we actually can now determine from an ACI perspective to what ports on the fabric all of this is connected. But why are we doing this? Well, if I go and talk with customers, what they tell me is that a big challenge in their environments, why they move into these automated infrastructures, is they have a lot to provision and a lot to provision fast. And what do these VMware users need? Actually, what do the customers of this VMware user need? They need a VM. And that VM needs to connect to a port group. And that port group needs underlying a VLAN. And that VLAN needs to be configured on a switch port. And that means the network administrator needs to know this VM is going to run on those servers, because actually when it's in that ESXi server, it's also part of that cluster. So it means it's all those switches and all those ports. And then you need to figure out where to configure all that VLANs. And for myself, I find that a challenging operation. And you might have Excels to do that and manage all these things. And you need to manage what VLANs to use, et cetera, et cetera. But imagine you have a fabric that will automatically determine where a VM is, because we retrieve that information from vCenter, dynamically determines where in the fabric that VM is connected. And as that VM moves through the infrastructure, on-demand provisions that VLAN on that port. Because you know what? We actually don't want to pre-provision these VLANs because they burn hardware resources. And in large-scale data centers, hardware resources are very scarce. So you need to preserve them as much as you can. This also allows a much faster deployment. It means the VMware admin can just go into ACI, create an object called an EPG. We'll talk more about that in some minutes. Link it, and we're done. So keep that in mind. This is why we're doing this. We are doing this to make you to be able to deploy and provision in a much faster way. So I have my vSwitch and my servers are connected. What do I do next? Well, next is I bring my VM online. But to bring my VM online, I need a port group. If I need a port group, I need to create something in ACI which we call a tenant, an app, and an EPG. So the first thing I will do is I will create a tenant. And I will create a tenant called Cisco Live 19. I will create a VRF, Cisco Live 19. A tenant, think of it, if you know Nexus 7K, it's like a VDC. You know, it's like a restricted management domain. So we create this tenant, and in this tenant, we will create a folder to store our EPGs. Let's call it billing, and we'll put all our billing EPGs in there. Now, I'm assuming you're a little bit familiar with the concepts of ACI, but think of so the application profile, it is nothing more than a folder, and the EPGs, it is groups of VMs or servers, we call them endpoints, that share equivalent security requirements. It doesn't mean they're in the same VLAN, it doesn't mean they're in the same subnet. Forget about all those things. It is a group of endpoints that share the same network security requirements. All you need to remember. So let me create the first one, and I'm going to create a new EPG called web. And in my web, I will create a BD, BD01, and this will allow me to create a pervasive gateway that is active on all leaves in the fabric through a BD. I'm going to give it IP address 42.42.42.1/24. There you go, okay. Next, finish. My BD is created, finish. And I'm going to create a second application EPG called app. I'm going to call it app, and I will reuse my bridge domain that I've earlier created. Finish. And the next thing I will do is I will tell to my app, I would like you to assign this to the VMN domain that I have created. Submit. And I will tell it to my web, I would like to assign you to the VMM domain that I've created. There you go, submit. And if I go into vCenter, notice that some things have happened. I know in the back, again, it's really small, but just notice that there's 2 more items here. And it basically means 2 port groups have been created. And if I manage this distributed port group, and I go to VLAN, and again, you can't see it at the back, so trust me, it says 1035. So a VLAN is used by this port group because that's how VMware works. But that VLAN comes out of our VLAN pool of 1001 to 1100 that I assigned to the VMM domain. We didn't have to manage this in an Excel. This is automatically done for us by ACI. So what I can now do is, I can go to my VMs. I can take my first VM. I can put this VM on this port group. There you go. This is going to go under app. And I'm going to put my second VM on the second port group. And that is going to go under web. And if I, in ACI, go to the operational tab, you will notice, because I have connected a VM now in VMware to the port group, we have picked up, notice, learning sources VMM, that means information coming from vCenter, and we have discovered on NCAP 1068 for that port group, on those interfaces, that VM. And look, we already picked up the IP address. We picked up the endpoint, etc., and even the name of the endpoint, because we picked that up from vCenter. So it also means if I go on this VM, and let's take this VM, for example, I should now be able to ping my default gateway. This VM is IP address .101. The other VM is IP address .102. So let's ping first myself, and that's doable. I ping the other guy. I cannot ping the other VM. What did I miss? This room. You guys got good introductions in ACI. Excellent. Yes, we miss a contract. We need a contract for an EPG to be able to talk to an EPG. irregardless of who's in the EPG. Contracts is our way to allow things. So let me go to our interface for that, and let's go on my billing app, and we have this really nice, cool canvas where we can say, drop a contract from one EPG to another EPG. Say, because of course, you are a good company and you take security into mind, let's permit everything, you know, and we submit. Now let's have a look. We can ping. That's as simple as it is. You put contract in place, we put permit all, we can specify specific, we could have specified only ICMP or only port, you know, from the web to the app, you're probably going to go to a port 8080 to an application server. You can perfectly do things like that. Now, I hear you thinking now, Ramses, this is all nice. This is all in a virtual infrastructure. But what about my bare metals? Because you have bare metals. We are fully aware of that. So let's connect a bare metal system into the fabric. And to connect the bare metal system into the fabric, we use a similar, I'm waiting for my mouse to respond. One second. And I fear this is the demo factor. So let's have a look. Let's see. No. Yeah, but I did, that's a thing. Yeah, now we have it. Yeah, he was not accepting it. So, there you go. To add our bare metal into the fabric, we go back to our quick start access policies, and let's configure an interface port channel VPC. We connect again on the left to our switch policy. We're going to add a bare metal server on port 1/9. We're going to call it bare metal 01. CDP off, CDP on, that's okay. I'm going to create a new bare metal domain that I will call bare metal 01. And I'm going to use VLAN pool 1101 to 1110. That's not good. 10. There you go. Save. Save. Submit. And what I'll do now is I'll go to tenants, because now I just did the physical connectivity into the fabric. And I will now tell, well, this bare metal is connected to that specific EPG. So I will link it to the app EPG. So I will add a physical domain association. I will link it to the bare metal. And I will tell, and this is how ACI works, I will create something we call a static path. Deploy static path. I will say, well, you know, I would like you on leaf 1 on port 1/9 to create at VLAN 1101 access 802.1p. It's a static path untagged trunked, so 1101. And I'm also going to create that on leaf 2, because that's how my bare metal has been configured. So it's like a bond with active standby. So I don't know which one of the two is going to be active. So I'll trade 1.9. There we go. 1101. There you go. Submit. So we can now see that our static ports have been configured. There you go. And I'm going to take my bare metal, which is over here, and I will now ping the fabric 42.42.42.1, and I can ping it. I can ping 102. I can ping 101. Everything. And I can go to operational, and I can see my VM and my bare metal connected to this EPG. All without hardware VTAPs. You know, all without complex ways to bring virtual workload out of our fabric. If we would have had an SCVMM integration with Microsoft, an OpenStack integration, maybe with OpenShift, we would have had an integration with Kubernetes. It didn't matter. Everything could be connected to that same EPG. Any workload can live anywhere. Remember that, how easy it was to bring this bare metal workload into our fabric. Now, the last thing I promised you is to connect our fabric out to the internet. Because what are we with a fabric that can only talk internally? So in order to do that, I have a router, a Nexus 3K, that will allow us to route our traffic out of the setup. So let's have a look at that. So here's our Nexus 3K. I'm going to log into that. So on my Nexus 3K, I have a port channel configured. That's already there. It's not a session about Nexus OS here. So I have a port channel configured, port channel 11, with 2 links, 1/1 and 1/2. I have OSPF configured. I have a VLAN interface 900 that I will use for my point-to-point connections into ACI over SVIs. And I have a loopback 99.99.99.1. For all practical purposes, that's the internet. That is the route that I will announce through my fabric, which will mimic our internet. Okay? So, in order to create an L3 out, and the L3 outs we create in the tenants under networking, external routed, what do we first need to do before we create objects under tenants? What is it that we first do? What did we do for the VMM and for the bare metal first? We went, yes, to fabric access policies. So we will first make an access policy for our L3 out, so that the port channel can come up. The tenant configuration will create the protocols, the IPs, and everything on top of that. But first, we need the connectivity. So we will create an interface, port channel and VPC. We'll again create on the left, select the switch selector. We will select a VPC, and our Nexus 3K is connected on port 1/33 at each side of the fabric. And did you notice now, because this is symmetry, this is all I have to do. If this was not symmetric, I couldn't select switch 101 and 102 at the exact same time. And I would have to create a multitude of policies to actually get this to work. But because on both sides, leave 1 and leave 2, we are connected at the exact same ports, I can configure them in one go. So remember, ACI loves symmetry. We will say this is a VPC, CDP off, LLDP on, and we use as a port channel policy active. There we go. And we will create a new domain called external routed devices. So there you go. And we will call that domain, we will give it a name, Nexus 3K. And we will give it a VLAN pool, because again, that is the pool that we will use to pick VLANs from to make, for example, in our case, an SVI. Make sense? We click Save. We click Save. And we click Submit. We should now see on a Nexus 3K, and let's do term 1, yeah? Actually, I was on the console. I'm not sure here. So I think I was just in time. Show port channel summary. We see our port channel coming up. Does anything work? You know, because actually what I need to configure at ACI side is 82.82.82.1. Of course it doesn't work. We didn't configure that. So in access policies, we create our domains. We create our VLAN pools. We create our port channels, which we can then later on reuse from the tenant perspective. So that's an important thing to remember. Now, I'm going to do one quick thing because I need to do that a little bit early in the session, because at the end of the session, we're going to talk about software management. I'm going to do one little secret. And remember, I told you we have this special API. So what I'm doing now in a tool, I'm selecting software and I'm importing it into the fabric. Just remember that this happened. This is over the APIs. Later on, we'll get back, and we'll see that. So it's a little intermezzo. No software is now downloading. It takes 5-10 minutes, so we need to make sure we do that during the session. So the port channel to our Nexus 3K works. Good? So the next thing we need to do is we need to set up the peering. We need to set up the OSPF adjacencies between our fabric and the outside router. So in order to do that, we need to go to networking under our tenant, under external routed networks, and we create a new routed outside. Now this is the most complex thing that we will do today, so I have this helping thing. Now, every time I did this session, I wear this hat, and it worked. So I'll do the same now, and it should normally, this lucky charm has always helped me, because it's a lot of pop-ups, so bear with me while we do this. So we'll see. We'll create a new routed outside. Let's call it Nexus 3K. And we link it to a VRF. And we link it to an external routed domain. And what we will also do is we will say, well, we're going to run OSPF. It's a regular area, OSPF area ID 1, so that's OK. And we will now create a node profile. So in our node profile for our Nexus 3K outside, we will define, because it's OSPF, it's a routing protocol, we define our loopbacks. So I define my loopbacks for my first node. Let's say 1.1.1.1. Yeah. There you go. Router ID. Yeah, router ID. And we create, as for a second router, for a second leaf, the router ID. There you go. OK. Now we have to create, and I told you it's a little bit more complex. It's pop-up after pop-up after pop-up. So we're going to create an OSPF interface profile with Nexus 3K. And we're going to create in there, I think this is it for this one. Yeah. Next. We're going to create an OSPF profile, OSPF policy. So we're going to create a new one. This is for a Nexus 3K. We're going to say, look, there you go, and broadcast, because it's SVIs. And then the last thing we do next is we're going to create a routed, an SVI on our, he's thinking, there you go. We're going to create on our port channel, or virtual port channel that we have created, we're going to select that, Nexus 3K, and we're going to choose NCAP 900. Remember, 900 is part of the VLAN pool linked to our routed domain. So we're going to choose 900, and we're going to give it an IP address, 82.82.82.1/24. And we also give the other side an IP address, 82.82.82.2/24. Okay, and we're going to click OK. We're going to click OK. We're going to click OK. And we're going to click Next. And now what we will have to do is, we have a router now created, and it will route. But remember in ACI, how again do we allow EPGs to talk with each other? Through contracts. Now we can only link a contract to an L3 out when an L3 out has an EPG. So I have to create an EPG on this L3 out so I can actually allow contracts to be created. So I'm going to call this the internet. This is my EPG called the internet. I'm going to say, look, just match all my traffic. That's the easiest way. Okay? And finish. And now this is the hat now. So now the hat is taking care of it. If all goes well. Huh? Look at that. Sorry, SPF neighbors. There you go. The hat is open source. The design is available. If you still know somebody that knows how to create this, off you go. So we can see our OSPF came up. We can normally see show IP route. Our routes, see, 1111, 2222. All good? What was our subnet of our VM? Yeah, it's 42.42.42. It's 0/24 and it's not here. Well, did we allow, through contracts, for these EPGs to talk with each other? No, we didn't. These routes are not exported. That is not going to happen. There is still configuration we need to do. From an OSPF perspective, we're there, but we now, on a per subnet, on a per IP, whatever you choose, need to start allowing and disallowing traffic. So the first thing we need to do is we need to go to our EPG called Nexus 3 Internet under Networks. So here it is. And we need to say, you have a contract interface over here. We need to say, well, you know, provide a contract. You provide a contract internet that allows other people to consume that, consume your service. So we will create a contract called internet. And we will create a new one here, create a contract, internet. And in there we will create a subnet, subject, let's call it just internet, which is basically everything. And we'll create a filter that says permit all default. Update, okay, submit, update, and that's it. So now we are providing a contract called internet. And actually now if we go back to our application profile, we can now see from a billing perspective, in our topology, we can see nothing yet. See? So we have our normal contract permit all with our EPGs, and I know it's small at the back, but just think of the objects. At the bottom we have EPGs. So what we still need to do is, at an EPG level, we need to consume the internet contract. So we do this on the app, and we do this on the web. Consume. Yeah. Internet. Submit. And now we can see from a topology, and I know I can try to make it bigger, but it's just somehow, I'll do my best. Huh? So see, we have an L3 out, and we have our EPGs. I think at the back you can see that. So we have app, web, and internet, and we can clearly see, you even see the directions, you can see that we are consuming these contracts. So the blue one, the L3 out, is providing to the contract internet, and the orange arrows, they show that we are consuming it at the app and the web billing EPG. Let's have a look. Is it now there? Still not there. Can you repeat? Yes, so the gentleman is saying we need to propagate the VM network. Yes, you're right. So we put the contract in place now, so the EPGs can talk with each other. But what we didn't do is, and that is actually the nuance we need to do, we need to tell the BD, you are associated to a specific L3 out. Because imagine you make multiple L3 outs, which each have a default gateway. Where do you go? So what we do is, at a BD level, which is our bridge domain, we can go to our, in policy, under L3 configuration, and we have to associate the BD to an L3 out. Update. And now, let's go again. Still nothing. Still one thing we need to do. And this is, you know, it's a policy system. And there is sometimes a little bit of changes needed, but they are always at scale. So the last thing we need to do is, when we created the BD, and maybe I went a little bit faster and you didn't notice it, or you were focusing on all the other new things that you were learning, there is an option, advertise externally or not. This is to protect that subnet on the BD, because on a BD I can create multiple subnets. So you might not want to announce all subnets in a BD externally. So I'm going to tag this subnet as externally advertised. Submit. And he will tell me the impact. Very important. Where will this have an impact? I authorize that impact. And I will check again. There you go. 42.42.42.0 is available with equal cost routing over both 82.82.82.1 and 82.82.82.82.2, which are my two SVIs on leaf 1 and leaf 2. Anywhere in the fabric, if I would have 20 leaves, anywhere in the fabric where my workload is running, through the route reflectors, these external routes are now announced to 42.42.42.0, and everywhere this is now reachable. So if all goes well, remember, what is our internet? Our internet is 99.99.99.1. So if it all goes well, and I take a VM, which has, we have a default gateway over here configured. So normally, see, there you go. I can now ping the internet. If I would do the same over my bare metal, the exact same thing would work. So what we have done through our policies now is we have integrated both virtual workload, both physical workload into a fabric. 2 leaves, 100 leaves. I hope you understand it doesn't really matter. And we have activated outside routing. And in our case, we activated the default route, so we're now providing internet services to our data center in a controlled way. We're using contracts, and we're controlling north-south traffic based on those contracts. So, can you speak a little bit louder? Can we see what these? Yes, so on the leaf switches, you mean? Yeah? What? So let's take that offline at the end of the session. So yes, you can. So let's look, either on the spine or on the leaf. For all simplicity, I can quickly take a leaf one. So on the leaf one, what I can do is, a lot of the functionality that you know is implemented on these devices. I can do show VRF. I can do show IP route VRF. And this is my VRF, tenant CL19, etc. Now, from a spine perspective, remember, we're working with an overlay network on a spine that is irrelevant. Spine is just a VX part of the VXLAN topology, so you shouldn't worry about that. But on the leaves, you can see this spine. You can see this perfectly. What you can also see, because I'm showing this because this is how you probably feel comfortable, because these are comments that you have been using before. What you can also do is, you can go into the UI, you can go to Fabric, and you can go to Switches, Leaf Switches. Give me a second. Sorry, Inventory. Yeah, that's better. I was thinking I don't see what I need to see. I go to my Leaf. I go to, for example, my protocols. Takes a while. He's thinking about it. And I go to, for example, OSPF. And I go to my OSPF over here, and I see all equivalent information. But what does this mean? If the UI can see it, it's in the object model. It's accessible through our APIs. So we strongly advise you, stay away from the CLI. That's for TAC. That's for the troubleshooting guys. Don't worry too much about that. Use our UI to get these kind of information. So all of that is nicely exposed to the UI. Make sense? Okay. Let's look at the next part of our journey today. Yeah. To what, to? Yeah, so the question is, we assigned the layer tree out to a bridge domain? Yes. So the question is, look, why did you assign the layer tree out to a bridge domain? So if I have multiple layer tree outs and they all have a default route, which one am I going to use? So in order to solve that problem, also within a tenant, we can have multiple VRFs. So the complexity can increase drastically. So ACI makes no assumption, and you specifically link an BD, which is linked to EPGs, to an external L3 out. Now this is a good thing, because this means you can have hundreds of EPGs in your fabric without any access to your L3 out, which is typically in multi-tier setups what you have. So that means we will only expose to the BDs of the front end, to the subnets in there that you specifically wanted, the L3 out. Everything else stays within the fabric. So we can very granularly control that. If you have more questions on that, we can go over them offline at the end. So it's very granular control on these things. So that brings us to, I would like to upgrade my fabric. And I understand you will have to, because we are releasing features at an incredibly rapid pace. So in order to get our latest features, and in the data center space that is truly happening, I don't know if you watched all the announcements this week, but there have been a lot of them. For all of those, you often need to upgrade. So in order to do so, what do we need to do? Well, remember, we do this for, in our case, 2 leaves, 2 spines, 3 apex, but you could have had 100 leaves. It's the same steps. What we do is we load the software in the API controllers, both the apex software and the leaf spine software. Each one of them is one file. And you make sure that all your critical systems in your fabric, but hey, you're running a data center, are dual connected. You separate your setup in 2 groups. One group, second group. You upgrade first the controllers. Once the controllers are upgraded, you upgrade maintenance group 1, then you upgrade maintenance group 2. Okay? First of all of you are going to make a pinky promise to me. When you do an upgrade, you will go to cisco.com and read our release notes. Yes? Yes? Yes, excellent. Because our release notes, they tell you from what version can I go to what version. So make sure you read our release notes. Verify what you need to take into account. Verify any possible caveats that we are aware of as part of that upgrade scenario, etc. So please do that. We can avoid contact. And not that I don't want to speak to you, but when you're in contact with me, it typically means an annoying thing is happening. So let's try to avoid that. So I've done that little magical thing where I did a quick click. And what that quick click did was it imported over our REST APIs fully automatically the software into the fabric. You can see that over here. You can see our 2 softwares have been downloaded. Okay, so we have our code there. So the first thing we need to do is go to infrastructure. And first we upgrade our API controllers. So we schedule a controller upgrade. You pick a version. You click Upgrade Now, Submit. Notice at the top something very important. I have a critical fault and I have 2 major faults. I most likely want to go and have a look at them and resolve them before I continue, because they might have an impact on my upgrade. So I can go to the system, and I can go under System to the Faults tab, and I can try resolving those. Now, it's too deep for this session to try to resolve all of them. There's a session, for example, from a gentleman called Mio Jovanovic that will go a little bit deeper into these kind of faults and what you can do about it. So that's not the purpose of this session. But don't tell me you didn't see that there were faults, because there's a big warning that tells you there are faults, fix them. After you have done the infrastructure, we're not going to do that now because we're going to sit here and wait for an hour, 2 hours. We switch to the leaves and spines. I see you think already, no, Ram says an hour, 2 hours. I can't be, don't have management for an hour, 2 hours. No, don't forget. We do it controller per controller. Your management plane stays online. You keep capabilities and visibility into your network. Okay. Then we go to our nodes. And what we do is we schedule a node upgrade. We make a new upgrade group. Let's call it, for all simplicity, left. All my left switches, in my VPC pairs. And I say the target firmware is this. And I would like you to do this on leaf 101 and spine 201. And let's schedule it for later so he doesn't do it now. Submit. And I do the same for my right group. So I say, well, right. I say the target firmware is this. Schedule it later. And this is 102 called 202. This is how you will do this. You will create a left and a right. You maybe will create 50 groups. depending on how your data centers operate. You know better than us what devices can upgrade at what pace. Remember, there should be zero impact, because if all your clients are dual connected and they all have good port channels in place, strongly recommend you LACP there, because that will actually guarantee that the port channels are always guaranteed up. We use features such as graceful disconnect out of the fabric, where before we do anything on a leaf switch, we will gracefully shut down all the ports in the right sequence, so that the end host, although the switch is still online and doing its upgrade, the end hosts are automatically disconnected, a graceful LACP disconnect, and switch automatically over to the other side. So we'll make sure on our side we do all we can to make this as smooth as possible. On your side, make sure that the operating system or devices that you connect have the right stacks configured, that they can handle this, and that they are dual connected. This is your best test if you did it right. You'll notice during this maintenance window. And that's it. This will automatically upgrade your fabric, and you will be at the latest code with the latest and greatest features. All you need to do. Remember the pinky promise, you will read the release notes. And as a consequence of that, you have everything taken into account and all things are solved. So that brings us to our next subject. And I promised you that at the beginning of the session, some special consideration. And the first configuration I would like to talk about is the tap pool. So as I earlier said, the tap pool is used for tunnel endpoints address pool. It basically means every leaf, every spine, every VPC, everything we do in the fabric gets an IP. We are burning IPs out of that pool. That also means there is a certain size we need for our tap pools. The default we would recommend you is to use a /16. The minimum recommended is a /19. I would strongly recommend you to keep this big. Now you're going to ask me, how big? It depends on how many leaves and spines you have and how many VPCs you're going to create, etc., etc., etc. There's a calculator for that. People can help you with that. What we will also need is an infrastructure VLAN. An infrastructure VLAN is our internal in-band VLAN to manage all those components, because switches still have VLANs. So it allows AP to communicate to leaves and spines. But what you need to know and need to be aware of, where this infrastructure VLAN is normally unique within the fabric, there are ways and occasions where you stretch the VLAN out of the fabric. For example, in hypervisor integrations such as OpenStack and Kubernetes, we move that infrastructure VLAN outside of the fabric. And that also means, because we move it outside of the fabric, because a lot of these platforms do not implement, and in Linux we call it namespaces. Some people might know that, else think VRF, it's the same concept. You get into the following problem when you don't carefully pick your tap pool. Imagine on the right, I have my OpenStack controller, and the management address of my OpenStack controller is 10.142.36.35.67. And it has a default gateway, and behind the default gateway, it has an NTP server configured at 10.0.0.3. 10.0.0.35. Imagine for our special OpenStack integration, I extend my VLAN out of the fabric. I will also extend and get an IP address on my OpenStack controller, 10.0.0.95/16. I hope you realize I can't reach my NTP server anymore, because I have a more specific route, 10.0.0.0/16, can't reach it anymore. Because Linux will not implement namespaces for these kind of connectivities. So make sure that when you carve out this /16 in your network, that you keep these kind of things into consideration. Now you're going to tell me, but Ramses, I will change it later. I do this, and if ever that comes there, I will change it later. Now it's okay. And TAC is there to help you. So I'll tell you the procedure to change the infrastructure, VLAN, and the tap pool. And it's well documented. First, you log into your fabric and you take a backup. And you make sure that backup is really safe and you have the password written down 100 times. Then you delete all your controllers. all the content. You go to every leaf and spine, you delete all the configuration. You do an entire new fabric initialization, you discover the entire new fabric. The whole data center is down, by the way. You initialize the entire fabric again, you restore your backup, and you have changed the infrastructure VLAN and tap pool. So that's it, that's the procedure. At TAC, we're more than happy to help you. We understand you need help when you do this procedure. But we would strongly advise you when you plan, that you plan correctly. So take it big enough, carve it out, take it big enough. If needed, contact your Cisco account teams through maybe advanced services from CX to help you to do this sizing right. So we don't meet each other when we do this procedure. Okay, last thing, special consideration that I wanted to talk about is UCSB connectivity. And I've been showing this slide for the last 8 or 9 years, I think, at Cisco Live. And we still receive a significant amount of cases on this, so I'll keep on repeating it. When you look at, in general, blade chassis architectures, you typically look at a fabric interconnect-alike system that is typically connected to two northbound to two switches. We can see over here a fabric interconnect that is connected to an ACI leaf and to another ACI leaf. That we typically configure as a port channel. That is the easiest way to do. It's the highest way how that infrastructure becomes available. Now, do understand in the UCSB scenario, for example, between both fabric interconnects, there are cables. That those cables are only for cluster synchronization. They're not to make a VPC to the southbound part of it. So that means from fabric interconnect to the leaves, we can use a port channel policy. We can use a switch-dependent protocol such as LACP. But it also means at south of the fabric interconnect, from the blade to the fabric interconnect, you're looking at two independent links. So that means, and I don't know, and I told you I will explain you a little bit later, that means if I go to my virtual networking, when we have created our VMware integration, and I don't know if you remember that, we have created, and I think it's over here, a vSwitch policy where we have set, here, vSwitch policy, where we have set at vSwitch level use, it's loading, port channel policy, and we click on it, use MAC pinning physical. And I know it's a little bit weird because it's called VMM LACP leg policy. Very weird that it's called like that. That's what's in the name. But you see, we use MAC pinning physical load. If you're interested in that, there's actually a session in the catalog on my name that explains all these different load balancing protocols from hypervisor vendors and how that translates into Cisco or general networking terms. But this thing basically means MAC pinning plus physical NIC load. It means a switch-independent protocol. So we cannot use LACP. Remember that. And when you do this, when you misconfigure from your blade to the fabric interconnect and you say this is a port channel, my favorite is port on, mode on. Because LACP active is just not going to work. So typically they then choose mode on, which always works, of course. And the initial pings work because the hashing will only hash it over one side. The ping works. But the second they put load on it, we start flapping and it's over. So their calls are always interesting. No, it did work. Yes, it worked because you never had real load on it. So make sure you take this into account. It's a switch-independent protocol that you use over there, and that is also the reason, and when you rewatch this recording, you might notice it again, that I have chosen MAC pinning physical NIC load. Sadly enough, that brings us to the end of our session. So what I would like you to take away from this session is how easy it was to bring up this ACI fabric, how we could perfectly run virtual and physical workload in our fabric with simple operations, and how we could perfectly move our workload out. And also how we can, while guaranteeing a full online data center, how we could perfectly upgrade our fabric and get the benefits of new features in new releases. Let's continue our discussion in WebEx Teams. If you dropped questions during the session, I will respond to them today. So I will follow up on that in the afternoon, most likely. If you still have questions in the next weeks to come, I will do that. For the gentleman that asked some questions on automation, I'll drop some examples in there that you can do. So that should normally come. As always, if you liked the session, please fill in the survey. If you didn't, honestly, it's optional. So thank you very much for coming.